So this week we will bring you a double dose, if you like, in the sense that we're going to talk about two chapters. Of the remaining weeks we'll have at most one chapter, but this week we're going to cover both chapters 2 and 3. So if you have done economics in high school in the Netherlands, then you may already have seen some of the stuff that I'm going to discuss this week, but also next. But don't be fooled by that, because it will be at a much deeper level than what you have seen there, most probably. Anyhow, so let's start with chapter 2. And chapter 2 introduces the supply and demand model. So on this slide you can see the basic things we're going to do in this chapter. Describe the basics of supply and demand, use equations and graphs to represent them, and analyze markets for goods and services using this simple supply and demand model. Okay, so when we talk about microeconomics, we will often talk about markets, and a market is not really something specific, but something more abstract. So a market is to be thought of as something that is characterized by a specific product or service being bought and sold at a certain location and at a certain point in time. So one of my favorite examples will always be, say, the market for tomatoes. That's the product in Groningen, the location in a certain week, for example. So it doesn't have to be the physical market, that's the point, but it can be something more abstract than that. Look, here, that's my favorite example over there. And markets facilitate exchange, as we economists call it. In other words, they make it easier for people to exchange products and money, if you like. So what are supply and demand? Important question. So supply is simply the combined amount that all producers in a market are willing to sell. Demand is the amount that consumers are willing to buy, or whoever the demand is from. So this is the table from the book. The very simple supply and demand model has a couple of assumptions. We will focus on a single market. We will assume that all goods are completely identical, right? That's important. So the tomatoes that I'm going to buy in my market, I don't care who produces my tomatoes, because I cannot really tell the difference. All tomatoes are completely identical from my point of view. The third element is already an implication of that. So if all products are completely identical, that also means that they will sell for the same price. We'll also assume that everybody has the same information, and we assume that there are many producers and consumers in this market. And the reason that that is important is that the crucial assumption here is that nobody can individually affect the price. So there are many farmers that grow tomatoes, so if one single farmer is not able to influence the world price of tomatoes, say. So, of course, with every assumption, it's easy to come up with examples where that assumption is not satisfied. On the internet, people often pay different prices for the same product, for example. If you look at the market for computers, then clearly those are not identical products, etc. But in this course, and definitely in this first introduction, we're going to look at very simple markets of bulk products, many producers, many suppliers, and they all sell the exact same thing. Okay, so what determines demand? So what factors influence how much stuff people want to buy at a certain point in time, at a certain location? Well, there are quite a few things that are important, of course. If price is high, then chances are that people want to buy fewer tomatoes. If there are many people, if the number of citizens of Groningen doubles overnight, then chances are that more tomatoes will be sold at a given price. How rich people are, that's also going to determine their demand for tomatoes. Not really clear in what direction. Maybe tomatoes are not really a luxury product, so it could even be that if wealth goes up, demand goes down. We'll get more examples of that later. Tastes may change. Suddenly people may decide that they don't really like tomatoes, or there's some tomato disease that makes them reluctant to consume them. So that will also definitely have an influence on how many tomatoes they're going to want to consume, right? And the prices of other related goods. That's also going to be important. So if there are other things that people can buy, for example, cucumbers, then if cucumbers become really, really cheap, then that may affect the demand for tomatoes. And again, not really clear in what direction. You could argue if cucumbers are cheaper, people are going to consume less tomatoes because they're going to buy more cucumbers instead. But well, if people like to have cucumber tomato salads, then if cucumbers are going to be cheaper, then maybe demand for tomatoes goes up. But bottom line, there is a relation between the two. Okay, so that's lots of factors, but what we like to do is we like to make graphs, essentially. And the thing about a graph is that you can only put two things in there, right? So demand will be one thing, and we have to pick something else to put on the other axis. And the thing we're going to pick is going to be price. So in other words, we're going to make graphs, we're going to look at demand functions, and we're going to keep all those other things fixed. And for a given number of consumers, given consumer wealth, given consumer taste, given prices of other goods, ceteris paribus as we call it, we're going to draw a demand function for a product as a function of its price. So that's going to be my demand curve. That's going to describe the relation between the quantity demanded and the price, holding all other factors constant. So here is one, right? So here we have not tomatoes but oranges. On the horizontal axis we put the quantity, on the vertical axis we put the price, and then we can draw a curve. So first of all, suppose that people think that $6 is really a lot for oranges, and if the price is so high, they're not going to buy anything. So in other words, at a price of 6, demand is 0. If that is the case, then 6 is the demand choke price. As the price drops, people are going to want to buy more tomatoes, as you can see here. And what is my demand curve at the end of the day? That's simply a matter of connecting all the dots, as I've done here, and as is stated here as well. So that gives me my demand curve. Here's an important thing to note, to keep into account. If you look at mathematicians, well, what do we do if we draw graphs? Well, in mathematics, we have an x on the horizontal axis and we have a y on the vertical axis. So what does that mean? The cause, the x, the thing that causes something is always on the horizontal axis. And on the vertical axis is the function f of x, so the effect of x, if you like. Well, as you may have noted here, economists essentially do it the wrong way around, in the sense that I have prices here on the vertical axis, and I have quantity on the horizontal axis, but this is a demand function, right? And people are going to look at the price and on the basis of that decide how many tomatoes, or how many oranges, they want to buy. And so, in other words, demand is a function of price, yet I do have price on the vertical axis and demand on the horizontal axis. So that's a bit weird. Essentially, Marshall started that in 1870, and nobody has bothered to change that since. It has some advantages, by the way, but for now it's good to remember that. We have the cause on the vertical axis and the effect on the horizontal axis. We shall also give a mathematical description of the demand curve. So the curve that I just had, if you check, let me go back there, at a price of 0, demand is 2,400. At a price of 6, it is, at a price of 0, it is 6. It's a straight line, so if you play around with that, you can see that the demand function looks like this. So QD equals 2,400 minus 400p. P is the price, QD is the demand, as you can see here. So important thing to note, the thing we've drawn on this slide is not really a demand function, but technically, mathematically, it's an inverse demand function, right? Since the price is on the vertical axis. No problem, you can also calculate that. If you just solve this equality for P, then you end up with this inverse demand curve, if you like. So this is the demand curve, and that is the inverse demand curve. That's important to keep in mind. What about the other factors that influence demand? Well, I had those lists of other factors, right? I only have 2 dimensions to make my graph, so all other factors are assumed constant. So in other words, if any of those other factors changes, then my demand curve is going to shift, right? I'm not going to move along the demand curve, which happens if the price changes. If the price changes, I just move from one point on the curve to a different point on the curve. But if one of those other factors changes, then my whole curve is going to change. So there will be a shift in my curve. That's also stated here. So a movement along the demand curve is what you get if you change the price. And a change in demand is a change of the entire curve. So that's a terminology that's good to keep in mind. A change in the quantity demanded, you stick to the demand function, but you have a different point on the demand function. And a change in demand is a shift of the entire curve. So here's an example. Suppose that, here are my tomatoes again. Suppose that the blue line, D1, is the original demand function for tomatoes. Now suppose that tomatoes help cure cancer, is found in a study. Then what's going to happen is that the entire demand function is going to shift, and in this case it makes sense that it shifts outwards, right? For this reason, if tomatoes turn out to be even healthier than we thought, then at every given price, people are going to demand more tomatoes than before. So this entire curve is going to shift outwards. But if there's a health scare for whatever reason, then the opposite is true. At every price, people want to buy fewer tomatoes. So in that case, the demand function is going to shift inwards. Which brings us to supply. Well, the whole story about supply is very similar to demand, but from the other side of the market, of course. So what influences the supply of a good? Again, there will be price. If the price is higher, more people will be eager to sell tomatoes. The number of sellers, if there are more sellers, then obviously there will be more tomatoes in the market. Production costs related to technology. If producing tomatoes becomes much cheaper, then demand will be higher at a given price. Supply will be higher, of course. And sellers outside options would be another thing. Rather than tomatoes, you could also grow cucumbers. So that is also something that is going to influence supply. Again, similar story as before. Here we have our oranges again. Suppose that people do not want to sell prices if the price sell oranges if the price fall below $2, so that will be the choke price. But if prices increase, then obviously people are going to want to sell more oranges. So here's 1 point, and here's 1 point, and here's 1 point, and there's a point. And to get our supply curve, or rather our inverse supply curve, again, all we have to do is connect the dots, and that gives us the supply curve. Okay. We can do that mathematically again. The supply curve that we just had is given by this expression here. You can check that if you like. QS is now the supply. Again, P is the price. And you can also do the inverse supply curve. Same reason as before. If you think of this graph, then actually you have something with price on the vertical axis. So if you want to have this representation that we have here, then actually you have the inverse supply curve, and just rewriting the one on top there gives us the one down here. So that's the supply curve, and that's the inverse supply curve. Supply Q as a function of P, inverse supply P as a function of Q. Again, similar to what we had with demand, you can have a change in quantity supplied, then you move along the supply function. So you go to a different point simply because price changes. But you can also have a change in supply, which means that the entire curve is going to change. For example, if there's a faster harvester, it becomes easier to harvest tomatoes. Then at a given price, people now want to provide more tomatoes. But if there's a drought, then at the same price, people are able to supply fewer tomatoes. So in the first case, the supply function shifts to the right. In the second case, supply shifts to the left. Okay, so we have our demand curve, we have our supply curve. Let's now see what happens if we put them all together. Okay, let's do that. So there will be a point where there will be a price, usually, where the quantity supplied equals the quantity demanded, right? So we're going to call that the market equilibrium. So the market equilibrium occurs when the price of a good results in the quantity demanded equal to the quantity supplied. What about the equilibrium price? The equilibrium price is the only price at which the quantity demanded equals the quantity supplied. As is often the case in this course, it's easiest to show that in a picture. So here we have the same demand and supply functions that we had on the previous slides. What is the equilibrium? Well, in equilibrium, the equilibrium quantity QE has to equal the quantity demanded and the quantity supplied. Demand has to equal supply. So if you put these two equal to each other, then as I do here, then you can figure out which P goes with that, which P makes those two sides of this equality the same. If you solve for that, a few steps in between, you find that at that equilibrium price equals 4, again PE for equilibrium price. And to find the quantity, you can substitute that back into either the demand or the supply function, right? So here's the pro tip. The tip is to just do it in both, right? So in both cases, you should get 800. So that will be a good check to make sure that you indeed have the correct equilibrium price, both in the demand as well as in the supply function. That should give you the same quantity. There's the picture. So this is the demand function that I had before, the supply function that I had before. This is obviously the point where they intersect, which gives me a price of 4 and a quantity of 800. So that's nice. What if the price is not the equilibrium price? Well, again, the same picture as before, but so at price PE we have an equilibrium, but suppose that for some reason the price is higher than that. So we're here. In that case, supply equals this amount, Q as high, corresponding to point X, whereas demand is only this point here, right? So what is going on in this market? Well, supply is higher than demand, and the difference between the two is the difference between QS high and QD high. That is my excess supply. If price is low, the opposite is true. Now my demand is higher than my supply, which means that I have an excess demand, right? QD low minus QS low. So, as I announced, here is a small quiz here to test your understanding of the previous material. So, before you continue the video, please make sure that you're able to answer these questions. And I will give you the answer in a short while. So if a demand function is supply function, the question is to determine inverse demand and inverse supply, and also the market equilibrium price and quantity. Good luck.